Hello and welcome. My name is Monica Miller. I am a developer advocate here at Starburst, and I am so excited to spend this time with you. We are going to walk through a very quick demo. We are actually going to be building a data pipeline in our data lakehouse very quickly with multiple different data sources. And essentially, what we're going to be doing is building out that entire pipeline from discovery to the end of, building out the data for your data consumers. We are going to be using a medallion architecture, which you can see here as the three different layers in our data lake. We will be using S3 and we'll be building out our bronze, silver, and gold architecture layers. Now, even more exciting, in our data lakehouse, we are going to be using Trino and Iceberg. So Iceberg was actually developed to be used with Trino at Netflix, and really those two give the combination of the awesome compute engine or the query engine, as well as the table format to really up-level your data lake from regular data lake to actually add those data warehouse-like capabilities to your data lake, creating the data lakehouse. So we're really excited about that combination here at Starburst. We believe a lot, that obviously we believe that Trino is the best query engine out there for you. And we're so excited we have a lot of people utilizing and picking up the combination of Trino and Iceberg together. So with that, I'm going to talk through so we can get started a little bit on the specific project that we have. If you have any questions throughout any of this demo, please go ahead and throw them in the chat. I'm so happy to answer. And then we can just keep the conversation going as we go through. So essentially what we're going to be doing today is we are actually going to be building out, like I mentioned, that data lakehouse-like architecture, and we're going to be basing it all in S3. Now we're pretending that we are data engineers at Nintendo and we need to get some information for some Pokemon spawns for the game Pokemon Go, which are existing in the San Francisco Bay region. So specifically what we're trying to do is narrow down all of this geolocation data that's coming in from all across the country, and we're going to narrow it down to just one specific region. We're going to be doing some transformations, transforming our data throughout the way, and you can see we'll also be converting it from Hive to Iceberg. Now, one of the interesting things here is that the geolocation data you can see coming in from S3 for the Pokemon Go data only has latitude and longitude. It doesn't have any of the information that we'll actually need for our end consumers on the marketing department. That's all found in the Snowflake Pokédex. So one thing we'll have to do is actually create a process, or we'll use Starburst Galaxy here in Trino underlying to actually combine our data from those multiple different sources into that one data product that will push through to our data consumers. So really that's just showing the power of federation, being able to pull in that data from multiple sources. You can have your data lake be sort of your center of gravity for all of your data, but then you're still able to access data that may live in the surrounding orbit. Maybe you don't want to move all of the data in. So that's what we'll be doing today. We'll be doing federation, building our data lakehouse, and then we'll be securing and governing it because, there are a lot of components that you need. We'll also be doing some updates as we need to the data and doing those data transformations, cleaning it, and bringing y'all in. So with that, I'm going to get started. We're going to first jump into Starburst Galaxy, where we're going to look at the two data sources that I've connected. So you can see this Pokemon cluster here that I have. We have two different data sources connected to that compute cluster. I'm going to go through and show you each of them and the connections just so we can kind of talk about it before we move forward. So here you can see my AWS Pokemon connection. If I actually go back and show you the connection, I'm going to collapse that here so we can go in and edit the configuration. You can see here all you need for your data lake-centric components is just the catalog name, some description, and then a type of authentication method. I chose to use my AWS access key for now. And then you can see there's different Metastore configuration options. You can actually choose between Hive, Glue, and Starburst Galaxy here. We just chose Starburst Galaxy for the ease of use. And we are allowing creating external tables in writing so that we can actually build throughout our data lakehouse. We've got our table format as Iceberg selected, and we are ready to go. You can then test that connection, get that response. The other data source that I have set up is that Snowflake lookup data source, like I mentioned. So I'm just going to go in here and show you that configuration. We've got our catalog name connecting to the Pokemon lookup, specifically that Pokédex. We're looking for that specific information to answer the final questions for our marketing team. We've got our Snowflake connection type, the database we're connecting to, the warehouse, and all of that information. So I'm just going to hit that test connection, and you can see we've got that response. So with those two catalogs, the next thing we've done is created a compute cluster that we can use to actually get the information from those catalogs. That's how Trino is utilized. If we want to look at the components of, we have a Starburst 101 if you want to dive deeper into a little bit more about Trino. That will be coming up in August. So if you want to learn more, stick with me there. But for now, we're just going to look at the cluster really quick and kind of show you the options that our cluster configuration can have. And so really what's really cool about Galaxy and even Starburst in general is Trino is so powerful with the ability to customize its clusters. And what we're trying to do here is give you the ability to not only customize, but customize easily. So scale easily, we do things like auto scaling, auto suspend so that your clusters will shut down. We're trying to get you the best bang for your buck there. And then really just, uptime and query caching to do all of the assists with your cluster that you may not have just in Trino. We also have 3 different execution modes. In Starburst Galaxy, we have the standard execution mode, which we're going to be utilizing because we're just using a free cluster. We're using the free tier. But we also have a fault-tolerant execution mode, which is really powerful for query-intensive or resource-intensive queries. So anything that takes a lot of compute power, maybe something you just want to make sure you add that extra oomph to so that dashboard doesn't fail. But we've essentially... Trino came out in 2022 with Project Tardigrade, which was, their fault-tolerant execution, refactorization, adding that cluster compute on it, and Starburst has just kind of up-leveled that a little bit to give you even more of that ability. And then we have the accelerated cluster mode, which is really, really cool stuff because it's the proprietary indexing and caching layer warp speed. And this helps you accelerate your data lake queries to about 4 times faster than we had thought previously, especially on if we get the right configurations for you. It can be super, super powerful. People have seen this really be beneficial for their data architectures. So those are just the different types of execution modes. And one of the things, like I said, auto suspend, auto scaling, we're really trying to help you tailor your cluster to your compute, to the workload that you're actually utilizing. So because we're utilizing a very low-key, specific workload today, we're only going to be using the standard cluster with the free tier. But if we needed to do something more powerful or we wanted faster queries, we could customize that as we needed necessary. So we've got that cluster configured. It is actually connected. I'm going to pop in here one more time to show you it's connected to those 2 different catalogs. And the last thing that we can say is that we have our cloud provider region of choice, but we can actually go multi-cloud and multi-region, which is super powerful as well. We've got our cluster connected. So then the next thing to do is actually move on to the querying. So we're going to start with this bronze layer, and we're actually going to get a little bit of an assist from schema discovery. What we're going to do is utilize schema discovery, which is a process that we've developed for our data lakes. Sorry, I clicked the wrong button. And essentially, it's going into that object storage and doing some of the information discovery for you. So instead of, specifically trying to figure out all the different information that might be on your JSON file or in your Parquet file, you can just run schema discovery and it will do a lot of that heavy lifting. When I was data engineer, regardless of it was the data lake or not, I spent a lot of time just trying to figure out what the data, where it lived, what it looked like. So this is a very handy tool to help you with that in that discovery process. So what I'm going to actually do is pop into that run discovery button. I'm just copying over the catalog URI that I need. So run discovery here, and I'm going to click the catalog. I'm going to leave it as discovered schema for now, and you can see here there are 2 different types of discovery that we can do. We can do incremental or full. Doesn't matter for the first run, but we can have all of that information here. So I'm going to click Run Discovery, and you can see here that we have a table that's been discovered as well as the schema that we'll need to put that table in. And I'm going to hit Create All Tables. So this is going to be the ingested Pokemon location data, which has basically the latitude, the longitude of all of the different Pokemon spawns in the Pokemon Go game. So if we click on the table here, you can see that it automatically picked up all of these different data types for all of our columns. It's got all of the columns identified, and then it even has all of the different, it looked at the text file and got the different escape character, all the things that we would need for the information to build out our table. So with this, we're going to actually pop over. It's going to schedule that discovery, and we are going to be able to go view that now discovery in the query editor. So I'm going to go back to the query editor, and I am going to open the Pokemon cluster, look at this cluster, and you'll see that discovered schema with that table that I have now available. If we pop open the columns, we'll see those columns match. So I'm just going to do a quick run to validate that that data makes sense. So you can see here, we'll run that basic select query just to get a view of what that data looks like. So we have the S2 ID, the S2 token, so an identifier, the latitude, longitude, and then the information about how long that Pokemon was there, as well as the Pokemon name and number. Now, here's what's really cool is we have completed the first layer, our bronze layer, pretty much without doing any sort of data transformation within, 3 minutes, which is so helpful when kickstarting the process, especially when you're trying to get started on, maybe you're trying to harden a query for the first time or harden a data pipeline. This is going to be very helpful when you're doing any sort of discovery and trying to actually create that data pipeline at first. So one thing I wanted to do really quickly is just show the create table statement for the discovered table that we had. It matches exactly what we saw on the other side of schema discovery. But the other thing I want to call attention to is this type hive. So really with this hive type, this is where we had no choice. This is how our data is being landed to us from our external third party or just our other internal data team at Nintendo. And what we need to do now is transform that data into a little bit more performant table format. We're going to be using Iceberg, and we want to actually use Parquet as well instead of just a regular text file. So that is part of our mission as we're building out our next layer of our data lakehouse, which is our silver layer. So we're actually going to do some transformations here. And in order to do that, I'm going to first just build a schema. So I'm just going to run create schema so that I can have somewhere separate for me to put the information that I'm doing any transformations on. We'll see that schema pop up here in a minute. As we run, it'll catch up to us. And then we're going to create the silver table, which is going to be very similar, except this time we're going to have the format as orc and a type as iceberg. So we picked this. Oh, I'm sorry, I forgot to set my schema. So I need to set my catalog and my schema so that I'm prepared to run going forward. But essentially what this is doing is it's running that create table statement. We're removing the columns we don't need, updating the table format type, and updating the file format type. So what we're going to do is now look at this query here, where we're going to be doing some transformations on the data that you saw in the discovered schema into our next step. So in our silver layer, we're going to be doing specifically a couple transformations. We're going to cast the data as a specific integer. We're going to round the latitude and longitude. We're actually going to do a data transformation here with this case statement where we're changing it from milliseconds to seconds. So if there is a millisecond count available, we'll actually make that into seconds. And then specifically, we're only pulling the latitude and longitude for the San Francisco Bay Area. That is all that the marketing team, our end consumers wanted. So we are transforming that data. We are making it smaller, and we're doing a basic insert into the table that we just created. Now, this is something that I'm showing you here as a historical load. We're doing basically just the historical load. If you wanted to build the real data pipeline, we would build out the incremental load on top of this. Essentially, so this is something that going forward, we would have some type of orchestrator associated. We also have a job scheduler in Starburst Galaxy, so you could potentially utilize that as well. But just use your favorite orchestrator, Airflow, Dagster, Prefect to essentially build out the incremental load on top, so building out that data pipeline. The next thing we're going to do is just kind of validate that the data in our silver layer that we created, those transformations, looks a little bit different. So you can see the encounter seconds got knocked off a little bit. It's a little bit of a smaller number. We divided by 1,000. Latitude and longitude are rounded. We got rid of the columns we didn't think we'd need. And then we also have the number and the name. So that is the data that we needed for our silver layer to then create our final consume layer in our gold layer, where that is ready to be, utilized by any sort of data consumer. And again, we have our data consumer in mind as that marketing team. Now, one thing we need to do before we go forward with that is actually figure out the data in our Pokemon Pokédex that lives in Snowflake. So one thing that we can do, we can run a select query from, as you can see here, we can preview the Snowflake data by running a select query. We can open it up, look inside here, get the lookup, get the information. But that's saying that we actually know what data we're supposed to be looking for. If we didn't, what we could do is utilize global search, and we could basically type one of our columns that we're looking for, and we can see that we have the asset match based off of global search, where it was able to figure out all of the different data dimensions that potentially match. And basically it does a lot of the manual looking up that you might have to do. You can just utilize universal search for that instead, which is a really handy tool when you're trying to cut down on all of the discovery work for doing that data. So I just wanted to kind of show that there, if you maybe didn't know what table you were supposed to be getting the lookup data from. But let's go ahead and just preview the lookup here. You can see we have the name, the number, the type is really what we're going to be focusing on here, type 1 and type 2. And then we have all of these definitions that are not changing, and that's why in this table it gets utilized a lot, which is why it lives in Snowflake. It is utilized by our data analysts a ton, and it needs to be there so that it's easy for them, but we're doing the heavy lifting of the compute in the data lakehouse. So the next thing we're going to do is just run a basic select statement where we're going to be federating the data from our data in the data lakehouse and our data in Snowflake. So I'm going to pop back over here really quick and show we're going to be combining the location data from here with the Pokédex data up here using Starburst Galaxy. So if we look at this query, you can see we have anything with the S prefix is actually the Pokemon spawn silver. So that is coming from our data lake. That's the data we transformed in our data lake. So the Pokemon Go location information. And then anything with the P prefix is actually going to be the Pokédex lookup, which is essentially the data that lives in Snowflake that we need to combine to get our full information. So we're looking at the type 1, type 2, and the catch rate. So here you can see something that's really powerful. We were able to run one query and actually combine data from two different sources into our select statement. So we could have a return for our interactive analytics, just ad hoc analytics. We could actually return the data from both two different locations, which is awesome when we're trying to build out and harden that data pipeline instead of doing all the work to move data from one location into another database just so we could combine them together. So I always get excited about that little piece. So our last step in the data pipeline is actually creating that gold table, or I guess our last layer is this gold table, and then we're going to create a view as well. So I am just going to run the basic select query that I just showed you. We're going to create a table from that. So this is combining both different sources. So we will eventually create a data product that combines both of the two sources together. So you can see we're just combining some of the columns that we need, specifically latitude and longitude, again, from that San Francisco Bay Area with the catch rate of interest to our marketing department. And the next thing we're going to do is actually create a specific view because we don't want our marketing team to be able to see everything that we did inside. So instead, we have a view for them. Oops, sorry, I clicked the wrong button. We have a view for them where we're going to just put the information that we want them to be able to see. So I'm just going to run the select statement there. It's basically creating a window function to find the total appearances for each view. So then I'm going to run that select statement and you can see what we've got here. We've got the type and the most popular Pokemon for each type and the total appearances. So with that, we basically run our data transformations in our data lakehouse. And the last part of that data lakehouse is to actually secure it. So, and create that data product. So I'm going to actually pop into our data products window. And what I want to do is basically show you all the different data products that you can create. Right now I have one available. It's actually shared with me. And so we're going to create that second data product and secure it properly for our marketing team. In order to do that, I'm going to go back to the data catalog. I'm going to open that data catalog. You can also do this in the query editor. And I am going to promote to a data catalog. I can actually add a bunch of different details. I can say, you know, this is the Pokemon spawns for San Francisco Bay. Shorthand, obviously, with our timing. You can add tags. So if we have any tags available, we can say this is maybe geolocation, SF region. We can even look inside, add specific link. You know, we'll add a contact as I am the one to be contacted in case this data has any issues. And you can see the two tables that we have available as well as the view that we need. We can also assign the privileges here. So what we want to do with this privilege is we want to make sure that the marketing team has access to look at that specific view. So I'm going to click on the view and I'm going to go in there and I'm going to hit the privileges button and I'm just going to add the specific privilege that I want to face. I want to add the marketing team role and I want them to be able to select from the table. I don't want them to be able to do anything else, just select. So I'm going to add that privilege. And then herein you can see if I actually navigate back to one of the other tables, we can look at specifically the lineage of the table. We can even pop out and see, you know, all of the different transformations that we've done. And specifically, if we look at that gold table, we can see the combination of the data from both the Pokédex and the silver layer. We can also look at the definition of the data. We can look at the preview. We can see the quality of the data and then metrics. And then one thing that we can do that we'll need to do for Iceberg tables too is actually do sort of the basically maintenance, table maintenance that you can do. We have that available for you instead of having to go through and do all of the work yourself. So we could actually create a job for that. If you have any questions about table maintenance, go ahead and reach out. So happy to point you in the right direction there. But we can do all of the work on the back end to help you with vacuuming, help you with any sort of cleaning up the old snapshots, making your Iceberg tables as performant as possible. But with that, getting back to the task at hand, I've got my schema that I want to promote to a data product, and I am going to label it as SF24 Pokemon. And we can add a description. As complex as possible, I'm going to say this is a description for now. And I'll show you one of the other descriptions that is way above. It's a markdown file or markdown format, so you can get really complicated. You can put in images, all of it as well. So I've promoted to a data product, and now we can see two different data products. Let me show you one that's a little bit more complex. You can see in here we've got a lot of different information, a lot of supporting links, a data model, so you can get as descriptive as you want in the specific data products that you have available. In the descriptions, I was just showing basic information. You can look at the data sets involved and really build out that final data product for you. So we've got our data product created and we've got it specifically from the marketing team. And if we were to switch roles, we would be able to see only that one data product. So that is a little bit about basically going through creating a data pipeline, securing that data pipeline specifically within your data lakehouse. If you have any questions related to any of the material, go ahead and let me know. My name is Monica. My email is monica.miller@starburstdata.com. And I'm happy to point you in the right direction or let you, ask any questions that you may have when you're going through all of this. So I hope this was beneficial, and thanks for spending some time with me. Have a good one.